We'll wait for like Scott to get back, but I'll just introduce and say hello and welcome everyone. Welcome to another month of the Austin Python Meetup. Thank you for coming, and thank you for all the people online who are here with us. This month, our speaker is me, which is funny, but Jacob's excited. Thank you, Jacob. And I'm going to be talking about building effective AI agents with a library called Fast Agent. And with that, I'll take it away. And that's usually what it is. So what is an agent? Was a question that was brought up in the previous conversation. And all an agent really is an LLM with a prompt and tools. So you can make tools. The new toolage is MCP tools that have been coming out and trying to be a standard, so that you can anything you write in code you can kind of deploy or use as an MCP server. So you can have like a send email tool, or you can have an add two numbers tool. It could be as simple or as complicated as you want. And then prompts are prompts. You're probably all familiar with prompting and telling it to be the best coder and to not make any mistakes every time. But here are some of the patterns that Anthropic's Building Effective Agents Guide goes through. They talk about two different pieces. They say there's workflows, which are a system where LLM tools are orchestrated through predicted code paths. And that's what's going to be this quick start guide where I go over. But then there's also more agentic systems, which are more dynamic and like free flow, like give this agent complicated tasks and see if it can like split it up and solve these tasks. Workflows is what they recommend because they're more like defined and codified. There's Fast Agent. You can use UV pip install Fast Agent, and then you can do their quick start workflow.
George, are you sharing? Because I don't see anything.
Oh, I'm not sharing. Thank you, Florin. I will send the links though. I'm gonna just send the links in the chat real quick if you want to look. UV is the new pip. It's the new pip. I've been in this command. You still use pip. I'm not actually 100% sure why all that's happening with UV. I think they have to update certain like if you use a poetry. You have to install pip. Like Python isn't packaged with pip, so you install UV as well. But you can do the UV install, and then I'm going to make this really big, and I'm just going to run UV run the Fast Agent Quick Start, and it's going to build me a folder called workflow, but I fixed it up slightly just so that it uses the Anthropic. I'm just using the Anthropic API key. So wait, I want to go to my Fast Agent config, and this is the configuration for Fast Agent. You can define your logger, like you want to save it to a file. You can save the level as debug. I'm going to save it to this context Fast Agent. It's a JSON-L file, so it's like structured logging, so you can kind of query it easier. We can go through an actual file later. The default model is not this anymore. Gemini has some problems with tool calling right now, as I've seen an issue with that. And then here are some of the MCP servers that will be used in the tutorial, and one that I've added myself. So in the tutorial, we're going to use server file system tools that will be able to run things like ls and go through your file system. And then you have an MCP fetch server, and that's going to fetch web pages and URLs that are given to it. And then this is a tool that I'll show you after for my own agent is called Desktop Commander, and that just lets you run just terminal CLI. So this is kind of where I've moved on my thinking of I was building a lot of MCP servers at first, but then I kind of realized that's not as necessary. It's kind of like an over-engineered abstraction when I could just use the current APIs and command line tools. But yes, with that, so that's the fast agent config. And we'll go into these workflows. And I'm just going to go right through the building efficient guide. We're going to start with prompt chaining. So we'll run the chaining example, and I'll show you the output of that. And we'll go through how simple it is to build these agents. So we have 2 agents. We have a URL fetcher agent with a prompt instruction, given a URL, provide a complete and comprehensive summary. It's got that fetch MCP server we saw in the config. And then I set all the models to Sonnet because I have an API key. And then we have a second agent called social media, and its prompt is to write a 200-character social media post for any given text, respond with the post, never use hashtags. And then we chain them together into a kind of an agent called post writer, and it's going to go fetcher and then social media person or social media agent. And we'll just send it a URL, and that's what we're running here. And let's see if we can go back to the top. So it got some HTML, it fetched some HTML. This is the fetcher. It's summarized the URL fetcher. It summarized this URL we gave it, website, technical capabilities, and then it gave it to the social media manager. But it looks like this time I ran it, it looks like it tried to fetch it as well. The social media manager tried to fetch it. But the end of it, we get our post. Transform your cloud desktop into a powerful AI hub, connecting it. Gives you some stats on your token usage and your context percentage window. And that's chaining. Chaining is, we call one LLM or one agent to call another agent. You could put things like gates in between the calls, so you could fail it or you could push it to another different chain branch. And it's pretty, basic one. Some other examples are generating market copy that translate into different languages, writing an outline for a document, checking the document meets certain criteria. Yeah, any questions on chaining? Chaining is the basic, simple one. We can move on to routing. I think all the other ones are a little bit more fun. Routing is fun. It's give you the router. So I'll let it start running. Well, router, I'll have to go up to it. But you'll have a few agents now. You'll have an agent with a tool embedding to fetch URLs, like the other one. We'll have a code expert agent. You're the best coding engineer. You make no mistakes. Has access to the file system server. And then you'll have a general assistant agent, which is just knowledgeable about all sorts of things. My window's too small. Okay, so now we could ask it a question. Does anyone have a question to give it? What? You made a noise. Now you got to say something. Okay. Can you chain infinitely? Like to loop back into itself? That's a different example. You're getting ahead of us. There's an evaluator one, and you'll have a max iterations one. But can you tell me about chaining? And we'll see where it routes this question to. So, and then we have the fast API, the fast router, not fast API, fast agent router, and it will have all these agents to pick from, and we will route it. And it says that this question went to the general assistant. We can give it a different, what? Sorry, we can give it a different question, and then it will route that to the other. This is probably going to go to the URL fetcher assistant, and we will come back when that's done. But yeah, we have an LLM called like router that's going to read these things and then route it to the appropriate agent. And
quick question. When you define those agents that it got routed to, is that only allowed to do a single LLM call, or can it do multiple LLM calls with that agent?
so these will do one call. Like how this example is structured is it's going to make one call to these LLMs, I think. So you can have it, go back and refine with feedback. And you can obviously merge these patterns together. These aren't like to be used alone. They're like you build with them. And this one used the fetch agent, fetcher, and
maybe because it's using these this router, is that like it make it superior to just opening up like a single chat window and just working with a single agent?
I think so, because I don't know if this is part later, but you guys use this Claude Code sub agents. I love the sub agents all right now. Okay, well, this is this uses routing principle. So in Claude Code, you can now make sub agents. So you can have a sub agent that's like, I have a sub agent that does pre-commit issues, fix all my pre-commit hook issues. Because now I can save my regular context from filling it up with pre-commit hook issues. Because when you build your regular context, you build it with all your business, you want it to be really good. You don't want to distract it with like pre-commit hook issues or like all nonsense context that's going to blow up your window, and then you might fall into model collapse, or you might make a wrong turn with it. So yeah, I think the routing pattern is definitely useful in this task of Claude Code uses it for sub agents. You can have a sub agent that does, fetch a URL, research something, debug, test, be my tester. And whatnot. Was that part of your question? Are they useful?
Sure. Yeah.
Sure. And moving on, we could go to parallelization. Now, parallelization has two different ones. This example has only one use of parallelization. And I'll go through that one quick, and then I'll talk about the other. Oh. Short story. Little hiccup here. I think when I changed this. But we'll go through the agents here. So we'll have a proofreader agent, review the story, grammar, spelling mistakes, punctuation. Fact checker to verify the consistency within this short story, and I'll show you the short story in a second. We'll do the style enforcer for style guides, narrator flow, tone. And then we have this grader agent, which is compile the feedback from all these things into a structured report. So I kind of take all those things, I run them all, and then I bring them all into this grader. And that's how it's here in the parallel. We fan out, and we run all of these three agents in parallel on the same story, and then we bring them all back into the grader. And that's what's shown in this diagram of you put all your LLMs into this aggregator as the fan in. And I'll show you the short story is over. It's purposely written, poorly. The heart of Glimmerwood, a mystical forest, node for its radiant trees, small village. It's chartered, and yes. So we can kind of look through this report. It's all very verbose. Obviously, I'm not going to read the whole thing because it's very verbose, but each one of them, came out with their problems, priority revisions. They had some spelling mistakes somewhere, some tense or grammar issues, and it kind of came all back in this report. And it's the start of this report. Here's some high priority things to fix. Weaknesses of the story, style and structure, consistency, and it kind of implements this plan for us. And it gave us a grade of a C+, but with strong revisions, we could be a B+. And, you know, the output of all those tokens. Now, another way of running parallel is for voting. And that's an interesting one where you're running the same question multiple times to get different answers. And then you can go and aggregate them. So you can give them all the same exact problem, but maybe a different like part of the prompt of solution. And you could say like, yeah, try it with option 1, try it with option 2, try it with option 3. And then you'll have your aggregator go through the outputs of those and say, oh yeah, like we'll do that.
They not call that ensemble anymore?
Yeah, it's an ensemble, but it's an ensemble of agents. I guess instead of like an ensemble of experts or ensemble of trees.
Yeah, trees.
Yeah. So this is cool. Here's some other examples of for selection, implementing guardrails when one model instance processes user queries while another screens them for inappropriate content. So you can have obviously multiple agents just running on all the same exact content while in parallel. Voting, reviewing code for vulnerabilities where several different prompts review and flag code they find if they find a problem. Orchestration, the orchestrator workflow. This one is like kind of on the edge. I kind of think of this on the edge of like getting to like just straight agentic. But this one is, we'll have an author agent where it writes a story. It'll use the file system. We have, I don't think this one's used. This was used to make the short story. You're a poorly skilled writer who frequently makes mistakes. So that's where that short story came from. We have our regular finder. It goes to the URLs. We have a writer. You can write to the file systems and are tasked with user input, addressing it, writing to disk. We have a proofreader. You review the story for grammar, spelling, punctuation, and we kind of orchestrate this. So this is kind of more of like, it goes back and it refines things. And we're gonna have all our agents, and we have 3 iterations of our plan. So we have a max iterations. You could set that for like 20 or so. And then we're tasked, load the student short story, generate a report, feedback, proofread, use style, write a graded report in the same directory. Oh, I didn't run this yet. That's going, this is definitely, I should have ran this. This one's the only one that I really had to run first. This one takes the longest, but it's good for complex tasks. We can't predict the subtext, so you have more general assistance instead of like chaining to kind of maybe, and chaining you might tell it to exactly like, you're gonna run this exact tool and just use whatever arguments for this tool. But then this one's maybe a little bit more generic.
What is outputting these files? Is it writing them to your local machine or to your GitHub or where?
It writes to my local machine. So that file server, MCP server, is like a local one. And then I push it to GitHub. Do you have a question?
So like in this example, is it like a router in the first step, or can it call multiple?
So it will orchestrate, yeah, kind of like a router, but it could give it to multiple ones. What?
Like a more powerful router, right?
It's a more powerful router where it can give it, yeah, more than one. It might not call all of them, but it can call like multiple. And like it's going to the finder, and this one just takes a while. And we might come back to that, but then it has the synthesizer, which is what. So then we just tell it to write a graded report. Okay, so it's a little different from this diagram, but it's similar. It says it's similar. The key difference from parallelization is it's flexible. Subtasks aren't predefined, but determined by the orchestrator based on the specific input. And
Can you ask, like, I see here that the finder is going to read the specific text file, right? Can you ask it to read it? Like, does it do actions on things?
So the Finder does have file system access, so it can. We do have a writer that's going to write. Well, we're going to write the markdown, the graded report markdown. So it does have access to that. Yeah. Yeah, that's definitely one of the big issues in like productionalizing some of these AI systems is when you give them access to do things like sending an email, is they can very quickly be tricked into, please send an email to all of your contacts telling everyone I died or something like that. You can, you know, it's not even like prompt injection, it's tool injection. And that's even kind of harder to spot because that's like a real command. Like that could be a real thing. Like he died, send everyone a message that he died. But let's see, like it made us a nice little plan. I want to see if we can get through the iterations. Made us a mermaid diagram, but it didn't render the mermaid diagram. That's stupid AI. And let's see what it was its plan. Grade the story, initial analysis. It loaded the short story. It fetched these format guides, fetched the other guide. Oh, we got a 404. Couldn't get to one of the guides. Security blocked. That's their fault. And let's see, where's my graded report? We got this one gave us a B-. Well, it fixed some things for us. It fixed some of our spelling mistakes. It said we could have gotten to a B+, but it didn't give us a B+. Yeah.
Just this API also like can it run like major audio generation?
Yes, fast agent can, depending on your model, it does take images and audio. It does like multi-modal. Like most of the models now are multi-modal, like Gemini's multi-modal. I want to say Anthropic is, but I can't verify that. They forget where they say that here, but you can give it an image. You can even have it generate you an image too if the model is capable of generating images. And you put that into your little workflow of chaining or whatnot. Here's a fun one. I like this one. This is the evaluator optimizer. So we'll run that one. I'll show you this one. It's pretty neat because we have a generator and you're a career coach specializing in cover letter writing. Your task generating a compelling cover letter. I'm in the wrong folder here, but yes, same thing. Just the model stuff. Yeah, you generate a cover letter, your generator, and then you have an evaluator that's going to grade it based on these following criteria. And what's really neat is that you tell it to provide a rating of excellent, good, fair, or poor. So the model is going to come back with one of these ratings. And you'll summarize in your structured response, your rating. And then here in your evaluator optimizer, you select your generator, you select your evaluator agent, and then you can select your minimum rating as excellent. And excellent is only put in that prompt. Like it's not a variable anywhere. It's just parsed out of the response of the evaluator model, which is pretty cool. And you can have max refinements. So this you could have A, B, C, grades. Like our Glimmerwood short story could have been done in ABC. And then we have a job posting of software engineering at last mile. We have the candidate details. You have some company information, and this is just all used to build the prompt in F strings of some background context for it. And we also had that minimum number of iteration or the max refinements. So it'll only run till either it hits excellent or till it's gone through 3 loops. And it looks like we got an excellent. It does not need any more improvement. But let's see if we can see what the first started as.
Is it the same model that generates the response and then evaluates if it's excellent or if it's a different?
You can have it. So a nice thing about, oh, I made this too big, is you could set the model to be one Sonnet model, and then you can have the other model be Gemini, GPT, and they obviously don't share a context space. They're all session independent. And yeah, so we're going to go through and we're going to refine Mr. Alex Johnson's little cover letter here and see if we give it some ratings. So that's pretty cool of it refining itself. Similarly with the orchestration, it will go into a max refinement planning kind of stop.
What would happen if you put, because you said the like the excellent was just like stuffed into a
Mhm.
What would happen if you put something that wasn't one of the options for the bus?
That's probably where the max refinement comes from. I haven't explored exactly like if I like, you know, how it uses this. You need, so it does have like min rating is good. Let's see, does it have, oh, so it is set in the args, but I think that it should get parsed out.
It just makes me wonder, like, think about how to break it. So what if instead of excellent, you wrote like,
Yeah, right.
how would it interpret?
Like if it's just such an agent function, you might wait for it to pancake.
Yeah, it could wait for it to pancake. I believe so. Let's try it. I'm done trying it. I'm gonna try it right now. It's a live demo for a reason. Oh no, pancake is not a valid quantity rating. Then I lied. I lied. See, this is why it's good. I really thought I saw someone else's example with ABC. Let's see. Let's see A. Yeah, it might be an enum then. Okay. No, no.
But could you change, like, could you do that? That you could leave as expert, because like A above,
Yeah.
Oh, yeah.
provided rating, it's weird. Don't mind what you said, spend away.
Oh, it's very cheap because it's only like a couple thousand tokens.
When you use these different models, like how are you paying for that? Are there separate fees or custom skill set there?
Yeah, I'm using Anthropic model. You can get to the, I guess I don't want to show my key really, but you just go through their,
Just through Anthropic, right?
yeah, right now you could do it through OpenAPI. Yeah, you can go to any of them. There's something called Open Router, which has been pretty cool. So you could just like, you have all of them under one API key and it'll charge you depending on your usage. I haven't used it. Have you used it?
Oh, yeah.
Will the fast agent like can it kind of switch in between the vendors with providers like pretty seamlessly?
Yeah, so you can give each agent whatever model that they support, or they support like all of them, or like the big ones, I guess you could say. You can also run your own Olama server of whatever you wanted, your own local stuff. As long as it's compatible, like sometimes your tools have to be compatible. So like not all LLMs are tool compatible. Most of the newer ones nowadays are, but some of like the small ones from like maybe a couple months ago even might not be. Okay, so let's see. We got an excellent rating, but did we just keep going? Let's see how many tokens we use.
Like, no, we're rating it.
We're giving it an excellent.
Maybe
Not
was
urgent.
injected by.
Yeah, let's see. Definitely save. Oh, so yeah, wait, it's looking for the excellent. So it found an excellent. This iteration is significant improvement. So yeah, maybe it just graded everything very well. Something to play with more. Homework for you all. And that's the last pattern here until it goes to just the agentic workflows where it's human tells an LLM to do stuff. An LLM has its own environment of tools and whatnot, and then it gets some sentinel value and stops. But one more thing with fast agent is it has a human input. Like you can have it stop and wait for human input. And they just added elicitations from MCP, like support for elicitation from MCP servers, which is also sort of like human input. I think it's more just like it asks it a question about a parameter, an argument or something, from what I remember there. But this one will be like, oh, I have a question for you. Unless I pressed enter too quickly. So it wants a pattern. We'll do this. And then it got its pattern and it says, oh, your sequence is +2. Sorry, I didn't give you the prompt. Request human input when needed. Oh, that was the prompt, wasn't anything there. It kind of writes, oh, no. Agent, print the next number in the sequence, and then it asks for a sequence. And then we gave it that sequence, and it told us our next number. And those are Anthropic's best practices for workflows and agents. And that was it. Using this fast agent library, I'll show you one tool one agent that I have built with this. This was for a friend of mine who's a lawyer. And so every day he has to go to the Travis County Court website and look at their calendar, their web calendar, and see, did any of my court dates get moved or did the locations get changed? And he has paralegal do this. But every day someone has to do this. And I just made a little agent that will go fetch that URL. And then I give it the desktop commander CLI tool, and then I have a G calendar CLI tool. And so it reads the calendar and then updates my Google Calendar that I've shared with him so he can subscribe to it. And I gave it its own personal calendar. I think it's relatively safe because, and what I really do is I've actually started moving away from the MCP tools and just like, I'm just gonna go to function calling. And so I just have like scripts that will get the court data. And then I want to like save it all nice, just in case when it does make a mistake, I can replay that exact prompt. And I also save the state of the calendar. But the prompt for this is pretty like, it's a little verbose, but it's like, we're gonna fetch this. I already called these functions before I run the agent. And then it's like, it takes the file, it reads it, and then use this gcal. Here's the tools, here's the stuff available to you. Compare the missing appearances, sync the calendar. Should you reflect all court appointments? And then I don't even need this last line anymore because I just run it after. And that's got the CLI thing. And yeah, please analyze the court data and send it. And then it's pretty, I like to think it's pretty safe because if someone messes with the court website and tries to prompt inject me through the government court website, that's game over. Like, yeah, I don't care if you're an AI or not, but like, yeah, here's his little appointments. And if you ever need a personal attorney, you can go to Jaime Pasantes, great guy. And yeah, and that's some task that has been automated away. Oh no, we've automated away all of his paralegal's work. No, 1 30-second task at most, but now it's just like one less thing they have to worry about.
What's the value add of the AI agent here compared to just coding?
So that's a question that as I work with it more, is like you kind of realize that, yeah, I could just like parse out, like it comes out, I can get it to come back as a JSON response and then like parse out everything and then just like manually map everything. I could have done that, but I wanted to make an agent for my friend. So yeah, I think that a lot of problems, I think that where agents are going is that they're not going to be used at scale to like label all these things, but they are going to help people and engineers automate tasks that like have always been able to be automated, but now it's like you can do it quicker.
Yeah,
And
that's
so
what
it's
I'm getting at, is it faster to do it this way? But maybe parsing it isn't the problem. Maybe updating the calendar is.
yeah, and building like all that kind of foundation and like mappings and objects and whatnot to do that automation. It's like that would have probably taken a lot longer with a lot more testing, and now you have your little Claude code who can figure it out a lot, quicker, and you can test that. For small things like this, you could definitely throw this to Claude code and have it give you something pretty useful very, very quickly.
Well, I mean, I guess there are two types of speed. One is the speed, and the other is
So like, I think you can execute on a small task like this very quickly. I think the AI, like working on big tasks in company is still a challenge that I face, and I know other people face it as well. That it just doesn't know all your business context. You can put it in a RAG, you do all these things, but it can do like, it's good autocomplete. It's definitely great for planning. Like this is something that can be totally done in like one markdown file plan, like with no extra outside context needed. Like I could fit all the context about this problem in a markdown and not really worry about it. Like at work, when I get like a task, I think about it that way. If I could fill every last bit of context needed for that problem in the markdown, you could probably do it. But at work, it's like all these random acronyms and all these random people and things happen and change. So it's like harder to keep that up. Like I wouldn't try in one shot or like, go through that with that.
I wonder if there's an AI that will fuck Jira and fill out all Jira.
There is a MCP Atlassian server that goes to Jira and will pull in all your Jira tickets and can update them and can do that. But it's on the old SSE MCP version, so it's on a server-side event, and it constantly times out. So you have to like reconnect it. You have to prompt it to like, are you connected to Atlassian? No, okay, I will reconnect. And so I've stopped using it because that's horrible. Like there used to be a GitHub MCP that was like kind of popular, and it had like 60 tools. We had 60 tools, but it wasn't as good as just it using the GitHub CLI because it knows the GitHub CLI. It's been trained to use the GitHub CLI. And so there is a bit of a disconnect. I don't think there's an Atlassian CLI tool. There definitely might be, but I don't know of it.
What's like maybe the gap between like what you did here, like here update my calendar versus asking it like, okay, write a script to update my calendar. Like, because that would be like computationally efficient in the long run.
Yeah.
Obviously, I think it's probably more
So,
complicated task.
Yeah, but then it's like as the calendar moves, it's like, what do you want to up? Yeah, like you have to just be a little smarter with your algorithm. Like you can have a script that does it.
Business setting, the business would rather have an actual like code base instead of
Yeah.
prompts.
Oh yeah, for sure.
So for some,
It's definitely cheaper.
You expect stability. You don't expect it to change over time. Then yeah, like how good is AI at writing complicated code versus just running the executing
Yeah, it's definitely safer to write regular code and not call an LLM for everything. One of the design principles I've always thought is that you want to minimize human involvement and human interaction in any of your applications, and even more so with LLMs, you want to minimize that as much as possible. And so if you do that for this problem, you would get to a solution that you could just fully map it. You don't need any LLM calls. But as far as it was just the trade-off. The LLMs are more expensive, but they're more hopefully generalizable to other unstructured, unseen things.
George, I may not have understood what you said, but it seems to contradict with a humanism loop. Basic philosophy.
Well, I think in application, that's for training LLMs and working with these agents is you want to be a human in the loop. That's how you work with them. But I feel I'm just a back-end engineer. We have one web app, And I feel like even in the web app, I'm like, I want them to press as little buttons as possible, because then there's less mistakes and less things that I like will go wrong.
You're saying you want the AI to interact with the
I want to, like, if I have any, if we haven't, I haven't really like, this is the only AI solution I've really built. Like, even at work, I have like a little demo thing. It doesn't really work well, but I want to call the AI and let the AI make as few decisions as possible. And I want to programmatically put in as many guardrails in this computation as possible. But as far as like proof of concept is like, yes, at first you can just throw the whole thing at the LLM. Does it make any, like, does this problem make sense? Like, can it even do it like this? Like, that's how I did we do matching of products. So it's like, given these two products, are they, the same? It's like, yes. It's like, okay, that's my proof of concept. It works. But like now it's like, I want to write the queries that is going to fetch the data that I'm just going to give it. I'm not going to tell it to like go look for the data or go look through the web page.
I guess like in this example of the court, like you don't want to ask the AI like go to the Travis County court website and download, like you want to just give it.
I'm just going to make the curl. Yeah. And like I can build, like the URL has like a start and end date. So it's like, I don't want it to do, like at first I was like, call the date, run date, and then put a month from there. And I'm like, I don't even need to do that. I could just run the date command myself and then pipe that into the URL. And yeah, like giving it less surface area for attack and hallucinations, probably. I also wanted to, let me see, I put one more thing in the README. I think that it would be interesting to do. I also have all the context, and we can check the fast agent, what it looks like. Logs, sorry. That's not a log. These are what the logs look like. I'm not going to install Rainbow thing. If anyone knows structured logging, really fun. Really easy to query off these things now, and you could like use JQ. So maybe I just, nope. And then I do like JQ, you could get all like the messages maybe. And then you just like kind of move around the logs like that, instead of opposed to like reading human. Instead of everything being in the message, you can have different values throughout your logs. And you can find like all the ones that have command UVX or all the ones that use this server fetch tool.
Have you found the logs useful to like debug?
Right now, no, because I've been doing it all locally. So like the logs are also just like right on my screen. And I've just been tweaking the prompt off that. So, but I imagine that like as it gets deployed and you go one day, it says like this stopped working or this deleted things, you'll want to go back and you'll want to see like, oh yeah, like it got stuck in a loop of calling the gcal tool to like delete all my events. I've definitely seen that a lot on like Gemini tool calling, where in the Gemini CLI, where you like tell it to like read a file and then like summarize it and write it, and then it just like gets stuck in some weird writing loops where it's just like constantly calling the same writing tool like 10 times. I don't know. But yeah, I feel like you see something there. Maybe you have to tweak your prompt. But that's the game, guys. How's everyone doing online? And that's all. That was fast agents. Thank you.
I have a really dumb question. So is there any relationship between fast agents and the fast API?
Not that I know of.
Okay.
I've wondered that too, because I've heard of like there's fast MCP, and that's built on Scarlet, and so like that's shared with fast API. But I haven't seen it. I've looked at it, and I've not seen any reference of fast API. They just like the name. It's pretty fast. It's pretty fast to get running and going. And
How long has been around the project?
we will. Let's look. Fast agent.
Do you like features that can you do the production stuff? As far as you know, how many stars?
It's only got 3,000 stars. There's a couple of these. Anthropic's guide says you can even just use like the raw LLM and just kind of like build your own framework around it. There's this LangGraph from LangChain, which I actually haven't used. But you could try that. It looks very similar. Tools, prompt, model. But do you want to know how old it was? Let's see, let's
Probably
find.
not that relevant because this is so new, but I was wondering like how reliable it is to build something that's like production ready.
Well, I know that people have used like the Google ADK, and I've heard a lot of people have complained about a bug or some issues in that. I think you also get like a lot of extra, like this seems very minimal, like this is pretty minimal, like it doesn't like run an extra admin web server for you. So like for people, like we just do backend systems. We have our own like log, like internal stuff that we don't need all of that extra stuff. So it looks like it works for me. Let's see, I don't know how far back I can go here.
That's great. Yeah. Well, like,
I wanna go back.
See how popular it is. It's about like 2,000.
Yeah, let's go to the releases.
George, tell me when it's okay to stop the recording.
You can stop the recording whenever you want. We're pretty much done. We're just looking at things and questions. Looks like it started in March 2024. So it's been it's been a year. Wait, there's no way that it was there's no way it was from March. Yeah. There's no way it was from March 24 because MCP wasn't around in March 24. Yeah.
Yeah, March 24.
Like, okay, I'm thinking of like 2024. This is the day of the 24th. Sorry. So it's been months, not a year.
Oh,
So March 2025.
Yes, 2025. Because I'm like, yeah, all this stuff wasn't out in 2024.
I mean, relative to the age of MCPs, it's a substantial fraction of it.
Yeah, yeah. Yeah, basically the beginning of the year. I think of this was the year like when they released like DeepSeek was like the first like reasoning model, and then like having these MCP tools to kind of make it agentic, and like that was really the start of like this agentic year.
Just guessing based off the name, but the LangGraph, is that like LangChain, except that you can build like a decision tree off of the agents or something?
I think
Yeah.
that is true. Like there's some sort of like graphic.
I guess with the router, it's like you might add them out, you separate it into different agents for your routing point, but then your output's still in a single node.
But the difference is you have a graph of your computation. And so with the chain, you start at the beginning and you progress to the end. With a graph, the common thing in LangGraph is a React agent where it's got a decision node and a tool calling node. And so it can kind of go back and forth. So it can look at the results of the previous tool and say, oh, I want to call a different tool, or no, I've got enough information I want to give it to the user. But you can, so that React agent is kind of a simple graph that goes back and forth between. You can define any number of nodes and edges in a graph. So you can have like a writer, a predict, a reviewer, and have a whole bunch of different pieces.
Great, I'll see you tomorrow then.
All right, buddy, I'll see you tomorrow.
Uses the agent like to progress through the graph.
Oh, so the agent is the computation, and the steps are the node.
Okay.
So a step might be so a step of the agent executing would be a node.
Okay, makes sense.
And speaking of that, I saw there's the simple node in Fast Agent. Is the simple node equivalent to a React agent, or is there an analogy between something in Fast Agent and a React agent?
A simple node. Where would you see that?
Sorry, simple agent. Simple agent.
Was there a simple agent?
It was either on the fast agent webpage or the Android webpage.
I don't think there's a simple agent here, but it might be.
Sorry, basic agent. Sorry, basic.
There's like just the agent. The dot agent is like the basic simple agent, and that's all of them. But then you have like how you connect them, and you have different operators of the chain and the evaluator.
With an agent, like what is there a way that you could say do multiple steps?
That would be like chaining, but yeah.
Well, chaining
You can go.
like do
Yeah.
instead.
And then step B is a different session. Do steps.
Like, if, like for one
Providing
agent,
2 prompts in the same session.
I mean, you've got one prompt. So you say you've got an agent you've got 4 tools, and the agent then can decide which tools to run. And the agent has the flexibility to call, tool 1 and tool 4, and then be done, or tools 1, 2, 3, 4, or maybe
Yeah, I think that's just more in the agentic like system, as opposed to like workflows. Just like at the end where you have like an agent, you can kind of give it steps and then send it off to other agents possibly.
So in the cloud kind of best practices, is that a mapping to the fast agent?
Does this one go to fast agent? Not that's in there. Quick start. Not that I haven't really played around with this. I haven't really played around with this. I've just been doing like basic workflows. But
but I mean, I guess this.
George.
Yes.
One thing you said something about Dixie being the first reasoning model. No, O1 was.
yeah.
Yeah, so no near yet. There's a reason it's important. Anyway, I'm going to stop the recording now unless someone really wants to say something on the record. Is someone really wants to put something on the record? Check it out. Like,
For the record, no, record scratch. We're
okay, I'm stopping the recording. Thank you. It was a great talk.
Thank you.